Hello guys, welcome you all for this end-to-end session of AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. So hope you guys are enjoying the session. So we are enjoying that guys. So hope the same thing for you guys. So yeah, as we are mentioning like in the past like 4 to 5 sessions we have diving into the world of machine learning. Okay, so before coming to this session, make sure that you guys have a 100% understanding of whatever the things that we have done till this point, okay, so that only we can understand what we are going to say today, okay, because like you guys need to understand all the previous sessions. So if you guys have any doubts, make sure to ping us in the comment section. We are here to help you guys. So yeah, that's all about it. So before coming to the session, as always we are asking, right, make sure that you watched all the previous session videos so that you guys can understand what we are saying. So yeah, without wasting any time, just we will jump into today's session. So today's session is a continuation of previous session. That is, previous session is all about linear regression. So we have looked into what is linear regression, what is a formula for linear regression, what are the assumptions we need. That's it. Okay. I hope like if you guys have attended previous session, then you guys, if I say linear regression, something should be in your mind, right? Just post it in the comments. Okay, if you guys attended previous session, this is what I have asked you guys to remember whenever there is a linear regression. Okay, I hope let's see how many of you know about it. Okay, so yeah, so hope you all have sent a right answer in the comment section. Okay, yeah. So whenever it comes to linear regression in your mind, you need to have y is equal to mx plus c. That's it. Okay. Hope you guys have noted down or listed the right answers. So just let us jump into today's session. Today's session is evaluating the model fit. Okay, how we can evaluate this linear regression. Okay, first we're gonna see what are the metrics, and then there we're gonna see the description. Okay, so R squared, proportion of variance in the dependent variable explained by the model. Okay, I hope like if you guys know about variance. If you guys doesn't know about it, please make sure that you watched all the previous session videos where we will be explaining you what is variance. I think nearly 2 to 3 sessions. Okay, I'm right. Okay, because like I think with the together with the overfitting underfitting we have explained this variance. Okay, so whenever it comes to R squared, it is a matrix. Okay, that is available in order to evaluate the linear regression model. That is, it's a proportion of variance in the dependent variable explained by the model. So that's what R squared. And there is one more metric called as RMSE. That is root mean squared error. That is the average difference between the predicted and the actual value. So predicted value is the value which is predicted by our model. That is the linear regression model. Actual value is the value which is present in the data set itself. Okay. So I hope like now you guys can understand, right, what is predicted value and then actual value. Then mean absolute error, that is MAE. Okay, what is meant by MAE? Average absolute difference between the predicted and actual result. So I hope like above is the average difference. Okay, we will do the average and difference. Average absolute means if it is a negative value, it becomes a positive. It is positive, positive. So it will not have any signs. That's it. Okay. So these are the different ways how you can able to evaluate your linear regression model. Okay, so these are the 3 ways. I will not say this is only 3 ways that we are having. There are multiple ways having. So these are, I will say, it is a better and popular method. Okay, so hope you guys have understand. Yes sir, over to you.
Yes. So, guys, kindly watch all the sessions 5 to 10 times and do reinforced learning, absorb the information, digest the information, and also apply to all the assignments. So, write in the comment section what have you learned, how you're going to apply it, and what is your long term objective function for your career. So, evaluating model fit. So, for that we have matrix and we have description here. So R squared we use for evaluation when we are evaluating model fit. So it is proportion of variance in the dependent variable explained by the model. So RMSE, okay, root mean square error, average difference between predicted and actual value. Whatever is predicted and the actual value, it is going to find the difference in predicted and actual value. Okay, so mean absolute error, MAE, average absolute difference between predicted and actual value. So here we have explained it in previous sessions also. So mean absolute error is the average of absolute difference. Like whatever is the average of absolute difference between predicted and actual, that is what is called mean absolute error. So you can see word called mean in it, which means average absolute difference. Average means mean, right? So between predicted and actual value, that is what is called mean absolute error, MAE. So let's move to the other slide.
Yeah, sure, sir. Okay. So yeah, these are the evaluation models, evaluating the model that is the linear regression model. Let's see what else we are having next. Okay. Feature selection and pre-processing. Okay. So what is meant by feature selection? Identify the most relevant variables to include in the model. Okay. This is what the major thing I will say, because like if you are having a data set with 1,000 columns, you doesn't need all the 1,000 columns to predict the final result, right? You will be needing at least most important columns from those. Okay. Consider if you are just building a model, then you doesn't need to have all the 1,000 features. You can have something called as PC and LDA. You guys gonna learn that. Using that, you can reduce your 1,000 columns to only 10 to 20 components, that is 20 to 20 columns, which represent the entire 1,000 columns. Okay, like that you can go. That is what the feature selection. Then we are having something called as data cleaning, handling missing values and outliers. This thing you guys will be well versed, because like I hope like nearly 30 plus sessions we have done only these things. Okay, handling missing values and outliers. So that is data cleaning. Feature scaling. So standardizing or normalizing the data to improve model performance. Guys, this in the code itself we're gonna explain, but like now understand. Feature scaling is like standardizing or normalizing the data to improve the model performance. Consider, guys, we are having two columns, right? In one column there is one digit numbers only, like consider 0 to 9. In the another column we are having four digit numbers which start from uh, 4 ones to 4 nines. Okay, in one column you are having one digit number 1 to 9. In the next column you are having the four digit numbers from 4 ones to 4 9. Now you guys say me, as a human, which column you will be giving more priority? The column with four digits, right? Because like it looks like a big number. The model will also do it in the same manner. If it does in the same manner, what happens means it will just look into only the column with the four digits. Okay, give high priority to that. What happens means instead of learning or training, while training the model should learn, instead of learning it will memorize it. Okay, so it leads to overfitting problem. So what you need to do means you need to scale the things. That is, whether it is a single digit or whether it is a four digit number, you should scale in a manner like 0 to 1 or -1 to 1 or -2 to 2. Like it should, everything should be underlie within the same scale. Okay, consider you are having a data points from -1 to 1 in the first column and -1 to 1 in the second column. So there is no difference, right, as a human itself. So the model will also have no difference. Okay, now when you train the model, it will generalize rather than memorizing it, so it will avoid the overfitting problem. Hope you guys have understand this feature scaling while we are working on the code. You guys can have a better understanding of what it is doing in the real time. Okay, so yeah, that's what about this feature selection and pre-processing. Yes, sir, over to you.
Yes. So feature selection and pre-processing, guys. Feature selection is identifying the most relevant variable to include the model. Like most relevant, okay? So because you need to find the most relevant, otherwise you'll have a lot of, and then there would be a lot of problems, right? Because your model will not learn if you give lot of features to the model. So you have to give most relevant model features so that it can. That is what is feature selection. You select features which are the best relevant for your model as per the objective function and characteristics of the data. Data cleaning, handling missing value and outliers. Okay, this is what data cleaning, you know that how to clean data. So you have to clean it. Like you get, you have different kinds of vegetables in your pitch or in your farm. So you don't put them into one basket or one particular bag, right? You classify, you put potatoes in different, tomatoes in different, all the vegetables you put in different brackets. All right, you collect. First they are raw, but then you classify, you put it into different. uh, so same way, when you're data cleaning, you have to see, handle the missing value. You have to see outliers. You'll not put the rotten vegetables into the good ones, right? They are the outliers, and then you will segregate. So you will not, so you'll keep the healthy ones for selling, or when people they sell or they eat. So, and then you classify, right? Same way, um, you have to have, you have to clean the data properly, right? So that you need to have that consciousness. Same problems are with data, guys, huh? And then feature scaling, standardizing, normalizing. So again, I'll tell you, like when you get mangoes, so you will see different mangoes are there in your farm, suppose. Then you select, you see grades, you have different grades, and then you put into different boxes, you grade it. Because why you do that? Because you are actually standardizing that, so that you can sell those boxes at different prices because of the quality. Same way, you have to standardize your data, you have to normalize your data based on the scale, so that you understand that. I'm giving example, right? You can apply anywhere this scaling, feature scaling. Again, we also do in fruits and different things. We do that feature scaling. Now we standardize. We have different prices for different qualities, export quality, domestic for normal use, for our so same way, you have to standardize, you have to normalize data to improve the model performance. There in the farm, you have, suppose the model is what? You again, you're not doing on it on computer, but model is to optimize your income, right? So that you standardize your things. So here again, model also has objective function. So you standardize and normalize data so that the performance of the model improves. Whatever objective function you have, so it will give the best outcome. So same way. So it's, if you see all those things we are doing in our real life, but we are not aware, and we don't know whether it is called feature scaling or data cleaning or feature selection, right? So even genetically, human beings have these things, right? When you see somebody, somebody very beautiful, so how you call that person beautiful, right? That is feature selection. And so again, there are features, there are behaviors, there are things, right? Same way, you need to bring that consciousness to data, guys. Why I'm giving real life examples, so that you can visualize in your brain that what I am saying. So I'm just giving ideas, food for thought, so that you can have your own ideas. See where is feature selection, where is data cleaning happening, where is feature scaling happening in real life, so that you will never forget these concepts. Okay, so always relate with real life, these concepts, so that you can remember for long term, build long term memory, and visualize. Sometimes will be wrong, exactly that concept doesn't mean, but till the time you find the right one, just go with it, understand it, absorb some. It's not 100% these things will be happening, but most of the things actually scientists have discovered observing life, observing behaviors, observing ultimately data, and data comes from real life. So as a data scientist, as a AI engineer, AI scientist, you have to observe life and data deeply so that you also understand these concepts properly. Let's move to the other slide.
Yeah, sure, sir. So moving on, we are having interpreting this regression coefficients. Okay. So till now we have seen linear regression, right? We have seen about the formula that we are using. Y is equal to mx plus c. So where y is the input variable, like output variable, which is dependent variable, which depends on the input variable x, which is independent variable, and we will be having a slope that is m, and then intercept is c. Okay. So how we can interpret this regression coefficient? That is what we're going to see in this slide. Okay. First is coefficient value, which indicates the strength and direction of relationship between the independent variable and the dependent variable. So coefficient means we are having c, right? So that is what the coefficient here they are representing. So this dependent and independent variable are x and y. What the C will do means it will say the strength and direction, whether it is a positively correlated or a negatively correlated, or whether there is no correlation. Based on the coefficient value, we can identify it. Okay. Next, positive coefficient. So that is a positive relationship, meaning increase in the independent variable leads to a increase in the dependent variable. As if you guys have watched the previous session, you guys can have a understanding of what is this positive coefficient and what is this increase in the linear like the independent variables value with respect to dependent variable. Okay, I will say an example. Like if you are study for an hour, then your mark is 1. Okay, 2 hours your mark is 2, and 3 hours your mark is 3. Now you can understand, like, there is a linear relationship and it is in an increasing manner. Whenever you are just able to increase your hour of study, right? When it is 1, your mark is 1. When it is 2, it is 2. So that is a positive correlation. Okay, consider you are studying for a 10 hour and you are getting only 1 mark. Okay, and 9 hours it is 2. So now the marks are reducing, right? So if an hour of study reduce, the mark increases. That means there is a negative coefficient. So this is what the positive and negative coefficient. Let's see. Negative coefficient is meaning it's an increase in the independent variable which leads to the decrease in the dependent variable. That's it. This is how the positive and negative coefficients occurs. So this is how you need to interpret the regression coefficient, that we are having y is equal to mx plus c, right? C, and how they are saying that positive and negative coefficient. Okay, then there is one more thing which is called as no correlation, which means when the data points, the relationship between two data points, whether it is not positive or negative, then that is called as a no correlation. Okay, we are having two data points. When there is no correlation, that is either positive or negative, then it is called as no correlation. So this is how you guys need to interpret the regression coefficients. So hope you guys have understand. So yeah, sir, over to you.
Yes. So interpreting regression coefficient, we are so it is like interpreting. We have to interpret. The model has to interpret, right? So whether we or model. So coefficient value, first is coefficient value. It indicates uh, strength and direction, strength and direction of the relationship between the dependent variable and the independent variable. It is, I'll tell you guys, the game here is in regression, dependent and independent variables. Game is on these things, okay? You have to understand that. So, okay. So there actually what happens, the actually hidden patterns are there in dependent and independent variable. There the black box thing happens there, and there it finds the hidden patterns and insights when it does, like when regression is done. So regression is what? You regress continuously till you reach to the actual value, optimal value, right? And with these components it will do that. So positive coefficient is positive relationship that increases the independent variable, leads to increase the dependent variable. So positive coefficient means positive relationship, simple, meaning in and like in positive relationship, meaning an increase in the independent variable. There is a increase in the independent variable leads to an increase in the dependent variable. So you can see like positive coefficient is going it's, if the independent variable leads increases, the dependent will also increase. That's what is positive correlation coefficient, sorry. Okay, so then we have negative coefficient. Negative coefficient is the relationship meaning an increase in the independent variable leads to decrease in the dependent variable. So in positive coefficient, both are increasing. You can see that behavior. Huh? And in negative, independent variable leads to decrease in dependent variable decreases. Okay, increase in independent, which is not dependent variable. What will happen? That when it increases, while it increases, but what happens in negative coefficient is that the dependent variable will decrease. That is the difference. That is the only difference to remember positive coefficient and negative coefficient. Okay. So in coefficient value, the it indicates the strength and direction of relationship between independent and dependent variable. That's the only thing. Coefficient value means it indicates strength and direction and of the relationship between independent and dependent. That is what you have to remember. Okay, and in positive, both are increasing. In negative, independent is increasing but dependent is decreasing. That is the simple way to remember, uh, like interpret the regression coefficients. This is what is interpreting uh, regression coefficient. I think I made it very simple, guys. So focus on the specific words and don't remember the entire text of definition. Just remember the interdependability. Like if you have positive, you okay. Positive means both are increasing, dependent and independent. Negative, independent. This is what you need to remember. In negative, you need to remember that independent variable is increasing, but dependent is decreasing. This is the technique so that you remember properly these concepts. So while you will build models, you will be conscious that what is happening with your model. Okay, I hope I made it very simple, guys. Okay, let's move to the other slide.
Yeah, sure, sir. So, guys, yeah, this is what interpreting the regression coefficient. Okay, so sir has makes everything very easier. Okay, like positive coefficient, negative coefficient, and coefficient values. Okay, so we will move on to the next slide. Okay, so yeah, so what are the applications of linear regression? We have just listed on some of the applications. Okay, first is the predictive modeling. That is, it forecasts the future outcomes such as sales, stock price, and customer chunks. Okay, so first thing, it is a prediction model. Okay, whenever you just give the data, it will gonna give the continuous values, right? Because this linear regression is comes under the category of regression, right? So regression means it's gonna give the continuous values. Okay, which is under supervised learning. We already know. Okay, so it is very helpful in the predictive modeling, where it is used to predict the future. That is, it forecasts the future. Okay, for example, let us consider we are having a humidity this much for a last consider last 7 days. Okay, so it is able to predict the eighth day based on the humidity values which it has for the last 7 days. Okay, so this is what the predictive modeling, where this linear regression plays a very important role. Okay, that is one of the application. Next, we are having data analysis, understanding the relationship between variables and identify the pattern. So I will say this data analysis, not that linear regression, whatever the algorithm we're going to learn in the future, right? Everything is going to work for this data analysis. Okay, so what is exactly data analysis means? We're gonna analyze the data. Okay, whenever we are having the data, we just gonna think like how they are correlated, what is the what is the pattern, what is the trend it is following, like that we will go for an analysis. So this linear regression, one thing which as an application in data analysis. Okay, next we are having optimization. So find the optimal value for the input to achieve the desired outcome. Okay, I will put it in the simple way. Y is equal to mx plus c, right? Y is the output value and x is the input. Okay, based on the value of m and c, you guys gonna get the y value, right? You will give the input, that is x. M is a slope and c is the intercept. What happens means, if you tube that, you gonna get the different y values, that is the outcome. Okay, so this is what the optimization, you need to get the optimal value for your coefficients of m and c. Okay, then only you can able to predict the y value that as you expected. Okay, finally we are having one more application, that is decision making, providing insights that support informed decision in various fields. Actually, I will say this decision making is like any field that you take, right? It is not just limited to data science. So actually, in the first session itself, we have just defined you guys. Data science is not a separate domain. It is something you need to have. That's a skill which will map to every domain, like healthcare. It can be an embedded system, or it can be anything like a banking sector. Anything. Okay, you just gonna align this data science knowledge to that domain so that you can make success on this. Okay, so this is what decision making says, that it provides an insight to support informed decision in any field. I will say it, instead of various fields, it's going to be any field. Okay, so these are the applications of linear regression that we are having. So I will not say this is the only applications we are having. These are, I will say, these are the important applications that we are having in the linear regression. So yeah, so yeah, sir, over to you.
Yeah. So, guys, application of linear regression. So, linear means line, regression means regressing till the time you reach to the optimal objective function of that particular model. Regress. If you see the word re means till that regression. So if you split the word regression, so this is how you remember, guys. This is how I remember things, because when I look at regression, I know that it is going to regress till the time it reaches the optimal. So that is the nature of regression. It can be linear, it can be polynomial, it can be anything. But that is nature. Then polynomial, it can be multiple dimensions, right? With multiple variables. But here we are talking linear regression, predicting model forecasting future outcomes such as sales, stock price, and customer. Okay, so this is, so the nature of regression, linear regression, it is continuous, right? So that is why sale is continuous by nature. You need to understand by nature things, problems by nature. Then you will be able to understand that why we are using linear regression in sales, stock market, because that's again a continuous problem. A customer crunch and stuff, or that's a continuous thing because they want products, stuff, and all, right? Data analysis, understanding relationship between variable and underlining patterns. See, the nature of regression is it regresses till it reaches the optimal. That is why it will identify the patterns. Okay, we human beings don't have that quality with us. We can build models, but we can't do that much of calculation in our head. So optimization, finding the optimal value for input variable to achieve the desired output, guys. Okay, finding the optimal value. What is the optimal value? And guys, this year optimal value for your model might be X, next year it might be X1. So always, and it also it changes. So you have to understand that you can't cage optimality. You have to always challenge the status quo, the current position. Status quo means current position. So we have to keep innovating, keep improving and learning and building new models. So finding the optimal value input variable to achieve desired outcome, which is desired outcome. Okay. So then decision making provides insights, supports informed decision on various fields. This is the power of linear regression, guys, when we do the application. So let's move to the others section.
Yeah, sure. So yeah, guys, this is all about linear regressions. Today we have seen a theory concept. I hope, like guys, last session and this session we have just explained you the theoretical knowledge of what is linear regression. Okay, we have started with what is linear regression, their formula, and then the nuances of linear regression. We have seen about how to interpret their coefficients, and then now we have seen about their application. Yeah, in the next session we're gonna see the coding part, guys. You guys gonna not gonna believe me, it not gonna take more than, I think, 2 lines of code for loading the model and then just training the model. Okay, so before that you guys need to know everything about this linear regression model, how it works, what is the formula behind it, what is the black box behind it, everything, guys. Okay, so yeah, this is all about this session. Hope you guys have enjoyed this session. If you guys have any doubts, just ping in the comment section. We are here to help you. We take up and we will just solve your doubt. So until next session, bye guys, take care, and we will all meet in the next session. Bye guys.
Yeah, so I'll again reiterate, guys. So go and watch all the sessions 5 to 10 times so that you'll do reinforcement learning and also absorb the information without bias and then digest the information without bias and then apply the information as required and then do all the assignments and write in the comment section feedback improvement if you want anything. So we'll be improving continuously. Keep learning deeply with persistency, consistency, and write in the comment section that what is your long-term objective function for your career so that we'll be adding more and more value with these sessions continuously so that you are continuously learning and become a lifelong learner. So go watch all the sessions 5 to 10 times, do reinforcement learning, continuous with persistence and patience, build long-term objective function for your career. Thanks a lot and subscribe to our channels. Also press the bell icon so that you can get notification for each session. Thanks a lot. See you in other session.
Yeah, guys.